Muchas gracias por asistir a este evento. Muchas gracias por asistir a este
about the online translation. We are going to turn to the people providing the interpretation
in order to provide information to participants who are in the
online translation.
About the online translation. Fiona, the room is for us with the translation.
Muchas gracias, Germán. Thank you, Germán. I'll start in Spanish. La interpretación ya ha sido habilitada. En la parte de abajo de su pantalla verán ustedes muchas gracias que se llama interpretación. I'll start in tiene una imagen de blog. Si necesitan interpretación, podrán hacer clic en la parte de icono y luego pantalla verán ustedes un icono que se llama, así recibirán la interpretación. Tiene una imagen de blog. Si necesitan interpretación, podrán hacer clic sobre este icono y luego seleccionar la opción de español. Así recibirán la interpretación del inglés hacia español. So the interpretation has already been enabled. If you need interpretation from Spanish into English, please click on this button called Interpretation with a globe icon and then select English. That way you will receive interpretation from Spanish into English. Thank you. Gracias.
Fiona, muchas gracias por la información.
Thank you, Fiona, for this information. So we're just going to give you a few seconds for you to choose the language that you wish to hear the conferences in. So please, go ahead.
We have few seconds for configure the language in which you want to listen to presentation. Comment, please.
So we're just going to give you a few seconds for you to choose the language that you wish to hear the conferences in. So please, go ahead.
Okay, y bueno, después de
that explanation, I'd like to welcome you to the conference that is called Metrology for Digital Transformation. My name is Germán Romero from the National Metrology Institute of Colombia. And as the Master of Ceremonies, I will be here as the Master of Ceremonies during these next 2 days. This event has also been being transmitted through Facebook and YouTube to different institutes. And I'd like to welcome all of those who are connected on social networks. And in the chat, you'll be able to see the link so that you can share the event with your colleagues. It's important to emphasize that this conference is organized by the Working Group 14 on the Inter-American SIM-MWG Institute, and I'd like to inform you that this is being recorded from beginning to end. The videos and the slides will be on the web page where you registered for this conference. It's also important, very important, to turn off your microphones and cameras. You can ask questions during the presentation by writing them in the chat. And once we've finished that presentation, then the speaker or speakers will answer your questions. So please, when you ask questions, please identify who the question is for. It's also important. You can also ask questions during the presentation. Well, as I was saying in the chat, please indicate also your name and the country that you're from. So now, in order to officially begin the presentation, I'm going to give the floor to Dr. Héctor Laiz to say a few words of welcome to this conference. Dr. Héctor Laiz received a diploma in electrical engineering from the University of Buenos Aires, Argentina, and a PhD in the Technical University of Brunswick, Germany. Since 2010, he has been the Director of Metrology and Quality of the National Industrial Metrology Institute, INTI, with the responsibility for all of the scientific metrology programs, industrial and legal metrology programs. He was the chair of the Inter-American Metrology System, SIM, and the Regional System of the Americas. In 2016, he was elected as a member of the International Committee of Weights and Measurements, and then in the International Convention, and this is why it's such an honor to have him with us. and for him to open this event. So please go ahead, Dr. Héctor Laiz. Thank you very much, Germán, for this introduction. It's a pleasure for me to be here today with all of you. Welcome all to this third event on metrology for digital transformation of the Inter-American metrology system. So today I am going to say a few words for the inauguration since the chair of the SIM wasn't able to be with us today. So I have the responsibility of starting this event. Digital transformation is a reality that we are facing in our daily lives. And there are aspects related to industry, health, and the society in general. And metrology should adapt to satisfying the demands for digital transformation and incorporating enabling technologies to provide metrological services that are adapted to this new industrial and social paradigm. In this context, the SIM, for the last 2-3 years, has been promoting the development of this topic among the institutes in the region, creating a working group, as we said, which focuses on supporting the development of this topic in all of the institutes in the region. These seminars that we are holding now for the third time, this is another milestone that we've been developing in the SIM, but it's not the only one. We do have other projects too that aim to develop these capacities, particularly with the Inter-American development, and they are supporting us with these activities. So we are very enthusiastic with this development, and I hope that this seminar will be fruitful and useful for all attending. So thank you for being with us, and let's continue with the presentations. Thank you, Dr. Laiz, for your words. And so, well, the third conference in different sectors and industrial processes. Right now, he is collaborating as a coordinator of the Metrology Task Force for Industry 4.0 of SIM, Metrology Working Group 14, Metrology for Digital Transformation. And thank you, Gabriel, for supporting us with this block. And now I'd like to introduce our first speaker. She is Pauline Henriquez, and she will be talking about digital transformation in Latin America and the Caribbean. Paulina is a specialist in the Division of Competitiveness, Technology and Innovation in the Inter-American Development Bank. She has specialized in digital transformation for businesses, entrepreneurship, and green innovation. She works also in the financial sector of an investment bank. Paulina has 2 master's degrees, one in engineering that she obtained in France, and other in business administration, and MBA from Columbia University, the USA. It's a privilege to have her participation in this event, and I'd like to give her the floor so that she can make a presentation. Go ahead, Paulina, and welcome. Thank you very much. Good morning and good afternoon, everybody. I'd like to greet you from Washington, and what I am going to present is a diagnosis on the digital transformation in Latin America and how this compares instruments and programs business digital transformation we are developing in the region. So thank you very much indeed for the invitation. We are very happy to be here, and it's an honor to participate. I am going to share my screen now. Let me know if you can see it well. Yes, we can. We can see it very well. Great, thank you. So what we've been experiencing in the recent years is forced digitalization because of COVID. And the question that we ask today is, what will happen with this forced digitalization? Is it here to stay, or was it just a temporary event? The figures that we can see nowadays, and you can see them here on the screen, tell us that it's here to stay. Some of examples, for example, in electronic trade, where the labor force and the companies use these electronic platforms, and this use is increasing. Online formats, online training, this is also increasing a great deal. And this is very good news, because with the level of digitalization in the region had been very low when we're thinking about business digitalization, starting with the most basic technology, for example, if a company has a web page or not. And we can see that, well, there are significant gaps between ourselves and other more advanced countries. And what we can see also in this graph is that for the medium and small enterprises, this gap is even larger. This segment of the small and medium enterprises is practically excluded. Here we can see the processes, the simple processes such as in banking, e-banking, or the procurement of supplies or digital sales channels. And we can see here that before the pandemic, our levels were quite incipient. And this reality can be observed with more sophisticated technologies too. As we advance towards more sophisticated technologies, we can see that the level of adoption is even lower. Artificial intelligence, for example, and we're going to talk about that during this initial block. In reality, it's just been 10% of the companies in the region that have these technologies. And if you delve into the details, we can see that these technologies are mainly reserved for the large companies. And also to conclude with this diagnosis, what's happening with digital talent? And well, this is very important so that we can have a pool of digital talent in order to develop the new technologies, but also to absorb them in the countries. And what we've been able to see also, we've been able to see considerable gaps with developed countries. And for example, over half the countries of the OECD. And when we look at skills, more advanced skills, such as programming, for example, we can also see that there is a big gap. And we can see that here in these charts. Just 5% of programmers are in the region of Latin America. And this represents 10% of the countries of the OECD. So what can we do about this? And I'm going to give you a couple of examples of programs that in the Inter-American Development Bank we have supported. In the bank, the topic of the digital transformation and support for competitiveness, and particularly for the small and medium enterprises, these are fundamental pillars for the vision for 2025. So this has been for the companies significant during the pandemic in order for them to continue to operate and to continue to sell. but also it's of key importance for economic reactivation, for providing more productivity and competitiveness to the companies, and to improve the efficiency and effectiveness of internal processes through digital tools, improving the supply of products based on data. And this isn't an easy path. The companies can't implement all of these technological innovations at the same time. It's a gradual path, and the companies need to start with the most basic, and that is having connectivity, having the infrastructure, and then progress towards the digitalization of processes. And we're speaking here about e-commerce, accounting processes, to take advantage of the digital processes and the data in order to change their business models and innovate and really approach this technological border. So I'd like to give you a couple of examples here in these 4 elements of the program of how we can support the medium and small enterprises that are really excluded at present. And so with the purchasing power, how this can be pushed forward. So a regulation, a cost-cutting regulation for, we're going to see that in all of the several examples. And finally, the digital enterprise. So now with the segment of the SME, this also is applicable for larger countries, and there are 5 main challenges here. One is an information and articulation situation, because there are lots of different types of training and tools and support, and it's very difficult for an SME to be able to navigate all of this information and to know where to start. Secondly, it's related to connectivity restrictions. There are gaps regarding the penetration in the region, and these have actually increased. And we see that there's a considerable heterogeneity with the countries, and in the same countries, we do face challenges, especially in rural areas, challenges with connectivity. Thirdly, and this is applicable to all technology projects that we've worked on in the bank, there's limitations to access to financing, and this limits the use of technology. And the ICT sector, which is still incipient in some countries, and not just the sector itself, but all of the supply of the support for the companies in order to adopt these technologies. And finally, what was mentioned before as well, the weakness regarding human capital for digital technologies. So in the bank, we have created a tool, a digital self-diagnostic tool called the Digital Check. And this makes it possible to determine the level of maturity. And there are 8 dimensions here, because it's not just a question of understanding the use and adoption of digital technologies, but also all of the different complementary elements that will really result in a real digital transformation. For example, the digital culture within a company, the analytical capacity and data, so that the company can take advantage of the data that are created at the level of digitalization of processes. So upon concluding this diagnosis, then a report is given to the SME about the level of digital maturity and some recommendations also for proceeding along that path. Obviously, this is advantageous for the SME so that they know exactly where to start and where what the destination is. But also at the level of the countries, because there is information is limited regarding the level of digitalization of the SMEs, and comparative information is necessary at the regional level. So data collection will allow us to understand this and be able to have a comparative view of the region. And there are many programs, dispersed programs, public programs, academic programs. So the idea is to coordinate this checkup with, or digital check with this world of digital support. So we started to launch this tool in Chile 3 years ago, and it spread to the rest of the region in recent years. And by the end of the year, the objective is to have full regional coverage for all of the countries of Latin America and the Caribbean, and then to develop the platform in order to visualize data so that each of the countries in the private, public, and academic sector can play with these data that will allow them to achieve a better understanding and use the data. This tool we've used in some programs to support the SMEs. It's a program in Uruguay with $15 million together with the National Development Agency. And this digital check coordinates or uses different instruments. We need different types of support depending on the level of maturity of the company. And also for those that are more incipient, it'll start with training, with access to the digital kits. These are kits full of basic tools. And then for the more advanced one, programs to provide technical assistance, specialized training, etc. The second block is related to how we can take advantage of the purchasing power of the state so that we can accelerate the digital transformation. And I'd like to give you a couple of examples here. The first one is in the construction sector. This is a sector that in our region represents 20% of the GDP. And a lot of this investment is from the public sector. But at the same time, this sector is the least digitalized one and the least, this is throughout the region. The problem with this sector is the lack of articulation between all of the sectors in these stages, different project stages, which means very often that information is lost, it doesn't flow well, they need to go back to plans, or the blueprints, make corrections, etc. So there is a methodology, a collaborative methodology, which is called a BIM, Building Information Modeling, which makes it possible to address these challenges of collaboration. So the BIM, well, it's a platform, a unique platform to consolidate all of the information related to a construction project where all actors will enter information on the same digital platform, and this is accessible in real time for all actors involved. And this generates savings and eliminates a certain delay and reduces emissions and the generation of residue. But this doesn't occur from one day to the next. The large companies have been using it for some time, but for the smaller segment, it's difficult to take this technological leap. There's a cultural issue here, a problem with resources too for adopting the technologies for training. And what's happened in many countries is that the list or the BIM, the BIM requires regulations, public regulations. So this only happens gradually. It can't be done from one day to the next. And also they provide support programs for the companies with training, financial support, generating a standard to use a common language between all the systems. This has happened in advanced economies in Europe for a long time now, but in the region it is still incipient. Chile and Brazil have been the first ones to publish these strategies and roadmaps, and we see that it is being promoted. This is very positive, and most of the countries are progressing towards this reality of digitalization in the construction sector. Secondly, this is an example of CPI, which is quite innovative, in which the government places a challenge to the industries, the innovation ecosystem. So in this case, in Uruguay, there was a need to have a new payment system, and they wanted to move it from a card system to a cell phone payment system. So this was an effort that included universities, enterprises, and this makes it possible to make a differential payment. It was necessary to define more efficient routes. And this has two advantages. First of all, for the public sector, because it makes it possible for them to become digitalized at the same speed as the private sector, and for the private sector to generate a significant market. And this is a challenge, particularly for the SMEs. But this needs adjustments and innovations too in the public procurement system. Even though this has happened in European countries some time ago, in our region, it's still incipient. So in the bank, we have been supporting this revision of the regulation so that the countries can progress and use this kind of instrument more. As I was saying, regulations, that's a very important topic, and it's a challenge as well, because the policymakers, the regulators, do face certain problems. For example, the speed of the technological change. There's always a lag between regulations, consumer protection, competition, when these technologies are adopted very quickly. We also face a challenge, a multi-sectorial challenge, because all of the sectors are permeating in this area of digital transformation, and it's sometimes difficult to understand what the responsibility of each is in collaborative projects. So this is an example in the United Kingdom of a test bed, and this is well known in the financial system, but these test beds exist. They are platforms, testing platforms for advanced technologies. And in this case, it was a collaborative project of the National Health Service, the National Health Service, NHS Innovate, and they wanted to start to test new technologies for medical devices, for example, to control patients remotely, early detection of chronic diseases with algorithms, but they didn't know how the national health system would respond. So through this challenge was launched, and the financial support was provided for these projects. Universities participated with the hospitals, also a home for providing care to elderly people, and regulators sat down to participate and observe and monitor the challenges that occurred. And this is a key area to develop this type of collaborative platform so that the regulators can feel comfortable with adopting the new technologies.
So as we were saying before, digital talent is extremely important because we have huge gaps, and it's extremely important to work with all areas from the most basic to the most advanced ones when we're referring to this topic. So we obviously need to work with the universities to update their curriculum, but this takes time. So what we've been developing is new, shorter models in order to update these digital capacities, such as the boot camps. The boot camps can be defined as an accelerator of digital skills, and in general terms, they take 3 to 6 months. They're not very long, and these are intensive courses that will allow them to become updated with these new technologies. That's the programmers. And what's interesting about these models is that they work with non-accredited startups, which have an employability approach, and that means that they're constantly updating they constantly require an update of their curriculum, and they must understand the demand, and they also support students so that they can become included in the work pool. And according to a study we conducted some time ago, we observed that 80% of the people graduating from these boot camps didn't have any prior computer or IT knowledge. We're finding work within the first few months after having left these boot camps or graduated from these boot camps. So it's a very efficient model to reduce these talent gaps in a quicker manner. So this model has grown globally, mainly in the United States, over the past few years. And what we've observed is that in Latin America, it's taking longer. So the bank has supported with the development of various programs in order to implement these boot camps and in order to provide support with scholarships so as to develop this market. And there are now more boot camps in the region. Lastly, there is a great potential when it comes to digital economy to address climate change. According to the International Energy Agency, it had estimated that 50% of the technological solutions needed in order to achieve net zero emissions by 2050 have not arrived or have not been included in our market. And so there is a study that's going to be included in the next few months on climate tech, and this is this refers to how only 2.4% of the companies participating in this area are located in the region. So this leads to it being necessary to take on more leadership, and very few of these companies are working in this sector. So there are many innovating solutions which are based on AI, and they can develop applications such as in the energy sector or in the intelligent distribution of energy networks or precision agriculture or sustainable supply chains, energetically efficient buildings, meteorological prediction, and disaster reduction. So there's an endless amount of solutions which we must work towards. And this is an incipient amount of tasks which need support through the strengthening of accelerators, incubators, financial support through the support of technological transfers. And we also must ensure that there is a serious alignment between the real needs of the countries and the supply, the proposal regarding new technologies. So that's what I wanted to say to give you an idea of the entrepreneurial digital economy in the region. There are many publications. You can see a few on this slide. Some of these have already been published. Some are going to be published in the next few months. So I'd like to invite you to check out the IDB's publications. Thank you for having invited me and for having listened to my presentation. And if you have any questions, you can send me an email. Pauline, thank you for your presentation, which shows us the scope of what the IDB is working on regarding digital transformation in Latin America and the Caribbean. And I would like to remind attendees that questions will be answered at the end of the presentations for this block. So you can send your presentations in through the chat. And we'd like to ask you to put in the name of the panelist the question is for. Now we have a presentation on Industry 4.0, and this presentation is going to be given by Antonio Sierra, who has a master's and a doctorate on electronic and automatic engineering from the Charles III University in Madrid. And he's been an academic researcher since 2003 at the Technological University in Panama. And he's an AI professor as well as a professor on technology and electronics. He has 12 years of experience in data science applied to electric markets, high tensions, biomedic, and acoustics. And he's also a consultant in energy transition and distributed generation. And thank you for being here, Antonio. We'd like to welcome you to this meeting. Go ahead, Antonio. Hello, everybody. My name is Antonio Sierra, but that is not my CV. I think you've given me a different CV. I appreciate this introduction. However, that doesn't refer to me. I think it might be the colleague speaking after my presentation. So I'm going to be talking about industrial revolution and transformation. So my name is Antonio Sierra. I work for the Transformation and Development Center. So I'm going to share my presentation. And please let me know if you can see it.
Sí, ya estamos viendo la
Yes, we can see your presentation.
Perfecto.
Great.
Y ahí la deben de ver ustedes en modo
And I'm sure you can now see it in presentation mode. Yes, we can see it in presentation mode. Thank you very much. So my presentation is going to be regarding digital transformation in the industry, and I'm going to talk to you a little bit about this topic. So the industrial revolution and digital transformation has been occurring since last century. We can see that since the 90s, there have been many retail companies that have begun with this transformation, despite the fact that we were physically buying at the stores. But now we can see digital transformation at home through applications such as Siri, Alexa, Echo, which are giving us information on things we have bought in the past, and which, based on our purchasing history, say, okay, you've bought this, and according to our standards, the product is about to be out of stock, so you need to buy some more in order to make sure you don't run out before it's out of stock. So during Holy Week of this year, I downloaded a series of YouTube videos, which I actually didn't have time to finish watching, but I thought they were interesting videos, and the application would say to me, look, I've observed you haven't finished watching these videos. I imagine that you don't have time, but if you watch this episode of this season, I'm sure you're going to find it interesting. It's a good summary of what's happened before. So this digital revolution is something that we face every day. And as Pedro Fabris mentioned at one point, we've lost the capacity of being amazed. And this is something that he said when they were launching a spaceship into space, because actually this week we saw saw that the project for launching a spaceship to the moon again had to be postponed. And in theory, this is going to be done this Saturday. But how many of us have just lost the capacity to feel amazed? Because for how many of us, think that this is just something normal? And for our children, it's now normal to be buying things online, because when most of us during the pandemic had to start buying things online, and for many of us, this was just something scary. I mean, it was scary to figure out how we were going to be buying things online. So, well, basically, digital transformation is here, it's here to stay, and it's a reality. And those of us who can take advantage of this in a positive manner are going to be able to benefit from this in the best way possible. So this used to be, transformation in an assembly line at a car factory in the past. And later I'm going to be talking about this pyramid, but now we have factories which are almost 100% autonomous, intelligent. So in Mexico, in the state of San Luis Potosí, there's a BMW manufacturing plant that actually complies or fulfills with this concept of intelligent manufacturing, autonomous intelligent manufacturing, because it's almost 100% autonomous. So before the Industrial Revolution, what we had was that we would produce products one by one, and we do it by hand, and we would combine effort because we had human beings and animals working together. So production is something that couldn't be consistent. We couldn't talk about complying with certain specifications. We couldn't talk about a quality culture because it was everything was done with our hands. So the first Industrial Revolution occurred towards the end of the 18th century in Great Britain, where what we began using was, mass manufacturing. That's when these concepts began rising. And we began producing at high levels, and we began using energy, and two types, hydraulic energy and steam. So final products began to be manufactured with machines, and we began substituting human and animal efforts with hydraulic energy and with energy created with steam. And we changed production that was production with our hands. And then the second Industrial Revolution at the end of the 19th century, at the beginning of the 20th century, we began using oil, gas, electricity, and we began creating assembly lines. And this allowed us to produce at high volumes. And that wasn't with too many products, in fact, because there's a saying by Henry Ford that said, everybody can buy a Ford of any color as long as it's black, because there were limitations. But mass production, gave us the possibility of sending products out to more people. So in addition to mass production, we began working with a certain degree of automation, and also communication by telephone and telegraph gave us additional possibilities gave industries additional possibilities, basically. And the third Industrial Revolution occurred in the 1960s, and computers allowed us to do interesting things. That's from the industrial point of view, because we began using logical programmable devices, and there's when we took serious steps towards automating certain processes in order to obtain information and sharing data. And now the third revolution also led us towards introducing clean energy. And here you can see an image of optic fiber. So this had an impact in all sectors of the industry. This is a photograph I like to share with people because it's a photograph of popular mechanics where there's a person from RAND Corporation said that at the beginning of this third industrial revolution in the 60s, said that computers were going to have a very large impact around the world, and that everybody was going to have the possibility of having a personal computer. And this image, you know, what you can see behind this person was showing what computers should be like in the future. And what I'm trying to highlight here is, well, the fact that people were convinced, or some people were convinced, that computers were going to be a part of our lives. And there were a few, well, technological, and scientific issues that had to be solved. But these people were sure that these aspects were going to be resolved, and that computers were one day going to reach everybody's homes. So this photograph, for those of us who were alive in the 60s, probably say a lot. So eventually we got to the fourth industrial revolution. That was that occurred in the 21st century, and that's what we all know as Industry 4.0, and that includes well, growing automation, the inclusion of intelligent devices, data that allow us to create a value chain, more flexibility in the industry. But this has also allowed us to manufacture, well, one product at a time again. So through the fourth revolution, which is called the digital revolution, we can now see the products we're buying. So at the moment, if you want to buy a vehicle, depending on the brand, you can establish what it is that you want specifically. So you can ask for it based on what you want. You can be specific on what you want, but the manufacturer, well, lets you know what the status, what the manufacturing status is of what it is that you're buying. So this fourth industrial revolution wouldn't be possible without this digital transformation we're talking about. So all of these concepts you see here, well, we need to explore them from a positive perspective. And when I'm talking about exploring them from a positive perspective, I'm talking about, well, you know, this, well, a book where Andrew Oppenheimer says, you know, we need to see digitalization concepts from a certain point of view, where we're saying, well, all work can be done by machines, robots, and we're going to be eliminating a lot of job posts or positions. No, we need to find a way to take advantage of digital transformation and train our personnel so that they can or so that we can provide jobs with a better added value, you know, for employees and for the companies. So in summary, this is these are the four industrial revolutions, and you can see the driver which has led to these industrial revolutions. So you can see science and well, quality of life, engineering sciences, mobility, electronics, and well, ICT. So this is what we've seen throughout the years, and now we're going through this fourth industrial revolution where we need to think about how we can take advantage of it. So from the industrial point of view, what would happen if somebody were to say to you that you can reduce costs or increase productivity through the incorporation of a certain methodologies, certain equipment, or certain pieces of technology in our factories. So you can increase manufacturing from 3 to 5% to 55 to 60%. I mean, I don't see anybody saying that anybody would say no to this. So Jim Collins, in one of his books, says that the best technology is any technology we need. So it's not the most advanced technology, it's the technology we need for our business. So we need to be capable to identify which technology we need and which technology is going to contribute the most to our business and provide us with the best benefits. So these values here were those reported in a study, and you can see the references or the reference at the bottom of the page. So now, through the Secretary of Industry in Spain, there was a self-diagnosis, and through SMEs as well, there was a diagnosis developed on the level of digital transformation in the companies. And they call this the Advanced Self-Diagnosis Tool, ADA. And this allows us to analyze 16 different areas, which you can see to the left of the slide. And on the outside of the circle, you can see the various topics, and which have been divided into 5 sections: business and market, processes, organization and people, infrastructure, and products and services. So through a free questionnaire, which has been posted online, we can see how or what the level of digitalization is in each of these areas. So now we have an introduction where we can observe what's going on, or we might be aware of things we're doing which can help us move forward. The second classification is the development section, and it has 2 categories: the competency category and the dynamic category, which shows that we're doing things, but we're not moving forward that much. And the dynamic area, it refers to the fact that I'm doing things in order to improve. And the next group is called the consolidation area, where I might be making, I might be operating as a reference in terms of digital transformation, or I might be a leader in digital transformation. So I'll be able to identify what the differences are between being a leader and my position. I'm going to develop my processes so as to continue moving forward, or I might be able to define what level I want to be at, so that this tool will help me establish where I want to be. So I'd like to use a very simple example regarding or developed by a development center, which is the center I work at, the center I lead, so as to establish what the product development process would be. So this is a very simple path that establishes what the process should be in order to develop a product. So we have the idea or product design, which eventually leads us to the moment where we place the product in the market. So here we have an image of a circular economy, and we must think about what we're going to be doing from the environmental perspective, as Pauline was saying in her presentation when she spoke about the actions for climate change. So when incorporating or when designing a product, we must consider certain factors. So now, when designing a product from the digitalization perspective or the digital transformation perspective, we must use software that will allow us to show the product, and this will also allow us to save resources when we introduce the product to the market. So a lot of what I'm going to include here is related to the automotive industry, because from my perspective, the automotive industry is one of the leaders in terms of material use, in terms of product design, when it comes to being environmentally friendly and using environmentally friendly products. So now, for example, a vehicle that's going to be in the market in 2030 is being designed today. So from this perspective, it's also technologically friendly, and we make sure that they comply with all specifications. Therefore, we need to work hard. So when designing the product, it's very important that we define what we're going to be offering in the market. So the image you see here to the left, this is a cable that we use in the mining industry. It's a cable that has LED lighting. So that's something we do through LED lighting in order to provide lighting within a mine. So in a mine, a cable can last for up to 3 months. So the first thing we did is that we modified it so that the operators and the large transport teams who can't see the cable in the floor, we had to find a way in order to avoid the mine workers from ruining the cable by mistake. So we worked hard in order to create this cable, this LED cable. So actually the life cycle of one of these cables could be up to 1 year, and if it's used adequately, we can double its life. So the advantages of not interrupting the work of a mineral extraction plant's operations and not suspending their work every 3 months in order to change these LED cables is extremely important. And okay, now during the second stage, we have to carry out testing. And you might ask yourself, well, what are we going to be testing? So for example, in the automotive industry, we have people saying, okay, if you are complying with certain specifications and you're testing fluid resistance, sealing chambers, etc., why is it that in the field the product might fail? So what this person was saying was, okay, you have to test, or you actually test each of these characteristics or each of these elements separately. But these elements operate simultaneously because you might have vibration, you might have contact with fluids or with oil, with many variables which are operating simultaneously within the product. So the prototypes have to be tested thinking about the fact that they're going to be subject to various conditions simultaneously, despite the fact that the standards say that they have to be tested separately. So it's extremely important to take this into consideration. And then this is something that we included in our risk analysis studies. But these risk analysis studies become more and more complex. And so what they do is that they slow down the process, or they require a large number of people. So what we need to do is we need to include digitalization tools in order to help us do this in a safer and more streamlined manner. Now, in the process design stage, we face the same situation. We have to check data online, and we have to make sure that the plant that's going to be producing those products I'm designing and developing in the investigation and research center can be transferred. So what we need to do is transfer the tools so that I can take the information from the productive processes so that I can ensure that I'm going to be able to repeat and reproduce everything so that the quality of the products is maintained the same. And there are tools that are important. That's the digital twins. Digital twins refer to the fact that I'm going to be able to reproduce those physical aspects in a digital manner. And once I reproduce them digitally, I'm going to make sure that I understand the process, and I'm going to be able to manage everything adequately, and that I'm going to be able to optimize and improve my products, and so that I'm also going to be able to implement benefits. Now, testing, I've spoken about testing. They're extremely important, but in a testing laboratory, I might not have the right resources when it comes to team and people in order to do what we're doing. So in order to launch an automotive harness, I must test up to 5,000 different specimens. And to do this within the right period of time, because I might have 3 months to do it, and that's a short period of time. But if I don't introduce the 4.0 industry techniques to the 4.0 laboratory, I'm not going to be able to do this within the right time frame. But so we need to think about the metrology concept, because in order for my reports to be valid for the Mexican accreditation entity or for our clients, I need to be able to prove to them that the results are reliable. And the most important aspect when developing a product, from my point of view, is for the metrology aspect, for the measurements to be able to done in a reliable manner. And I'm going to mention something else here. What we need is for our metrology partner to have similar digitalization tools so that we can all reduce the amount of time we take to do our tests and other processes. And for our partners, for those that are doing calibrations, to have the right tools. So we must all be connected. So what I say is, okay, I might not have something, but I think it's extremely important that we all have the right tools, because we have a system called Connect, where we have the equipment background information, including purchasing information, calibration. So I need to upload all reports, maintenance reports, calibration reports, etc.
So what would happen, for example, my partner in maintenance of calibration, if they send me directly the folder of the equipment is calibrated with its maintenance program completed, we're all going to gain time, and time is money for all of us. One important part as well that I would like to mention are the management systems. For me, a management system is a very powerful tool. We were the first research and development entity in Latin America certified for 1901. And we've got 9001, 14001, 50001, 17025 on laboratory management. We have 251 on information safety, or 2701. So this should be something that's completely transparent. And this is what I'm want to show you with this slide. We have a system that we call eDocs, and these are all of the documents in our management system used in the 8 processes that we've defined as being the most important ones. 3 main ones that are project services and testing. We have directing and improving and the integral system, and also procurement, human resources and maintenance. If as a user I need to use one of the processes or procedures related to any of these 8 main processes, I go into my system, I click on the one I need to get the information. I have to be transparent. So for me, the management systems need to be a culture, a habit, a discipline. It shouldn't be a response to an audit of the system. And finally, liberation. On the computer screen here, what you can see is what we deliver as a development center, a research and development center, to the plants, to the users. So if I'm going to liberate an electrical harness, such as the ones that you can see on the bottom right, what I need to say is which cable, which tool, which construction, what connectors, how I'm going to join them, how I'm going to measure the quality of the final product, how I'm going to generate the labels, what information I'm going to get from the process to provide feedback from my supervisor. And all of the folders that you can see there, they are specifically what we deliver as a package of technological transformation. So finally, in my opinion, digital transformation is an obligation because it's not because I'm convinced or because the client asks for it. This is either I am convinced, and for that reason I can take advantage economically of this, or maybe because my client is requesting this and otherwise he won't buy, so I'm afraid of losing the client. So the best way of using the digital transformation, or those who use the digital transformation, will have more competitive advantage over anybody else in the market. This is here to stay. We can't go back. We need it every day. Everything that I have needs to be transparent for the user. And through training, I should train people who are better prepared, that will provide better results. So as our friend Pedro was saying, let's not use this capacity to amaze, because if we lose that capacity, we're not going to be able to do greater and better things. So thank you very much. And any questions you have, I'm willing to answer. Thank you, Dr. Antonio Sierra, for your presentation. Before continuing, actually the information was addressed, and the information that we said at the beginning didn't correspond to Dr. Sierra. So now, just so that we all know his background, I'm going to detail it. He's a chemical engineer with a master's degree in chemical engineering from Manhattan College, specialized in the business direction, and a PhD in sciences of senior management. He's worked in Condumex, the director of the research and development Center Carso since 2009, a member of the National Researchers System in the area of technology. He participates in the program of the links to SME since 2008, and he participates in the management boards, electrical parts SA, industry and other companies, Concesoles SA, the research center and technical assistance of the state of Querétaro, and CDC and the National Institute of Optical and Electronic Physics at CENAWI. So Dr. Sierra, thank you very much for your participation. And I'd like to remind the participants that you can place your questions in the chat, and at the end of this block, we will be answering these questions. Now I'm going to give the floor to Dr. Hugo Gasca, who will send the presentation, a summary of the progress of the SIM Working Group 14 on digital transformation. Dr. Gasca is the president or chair of Working Group 14, Metrology for Digital Transformation, as well as collaborating as an active member of the National Mexican Researchers Network, and a member of the SIM Working Group on Statistics and Uncertainty, and vice chair of the EMECO Group on Digital Transformation. He has a PhD in mathematics and statistics, and since 2013, he started to collaborate with the National Metrology Center of Mexico, CENAM, as a management coordinator, leading the management of national standards, and as a specialized consultant in applied probability and statistics. It's a privilege, as always, to have his participation. Go ahead, Dr. Gasca. Thank you very much. Good morning, Herman. Thank you for connecting, everyone. I would like to share my screen now. Tell me when you can see it, please. Yes, we can see it, Dr. Gasca. Thank you. So it's going to be a summary, an overview in 15 minutes, because we're already a little bit behind with the agenda, about the developments related to digital transformation for metrology in the SIM, for the region of the Americas. We've already spoken about the terms, and I'm going to focus on ideas, but without repeating things. Héctor spoke about enabling technologies as in the future, and the possibilities for the future. And the only thing I'd like to say is that these are technologies that we are using, and it changes the way of looking at things and doing things. And of course, they are enabling because they allow us to do different things. So we're thinking about the cloud, big data, encryption, and we have progressed in quantical encryption, smart devices, or virtual instruments. Antonio Sierra spoke to us about Bitcoin and blockchain technologies, autonomous devices, logistics, design, etc. And something very important that's related to what Pauline was talking about, related to capacities and intelligence. We're thinking about the digital platforms for training and transferring skills and knowledge. This part of the appropriating these technologies. So, well, these are the enabling technologies, and all of these technologies have a scientific basis, of course. But as Antonio Sierra was saying, we face a significant challenge to make these references formal, and also with the characterization of these technologies, what level of uncertainty, what level of homogeneity. So we have everything here on the right, all of the instruments as well, the measurement instruments, all of the equipment at different levels, mechanical, optic, electronic, micro-component, synthetic, and this has all been mentioned before too. So all of this needs to be comparable worldwide so that people who acquire this can trust that they are obtaining results that are reliable and comparable with those in other countries or other companies. So to have for metrological traceability, as Dr. Sierra was saying, so that we can trust in these measurements. Another of the things that will be important for the future are to guarantee the reproducibility of these data. And here we're speaking about measurements and data that are executable or processable, and this will lead us to the metadata for describing these data, and this needs to be standardized so that what is produced in Mexico can be understood by machines in Chile or Germany or Canada or Belize or Trinidad and Tobago. So we're speaking here about the standardization of concepts. So what we have on the left of this slide, this will lead us to having virtual instruments, and we already have several of these in the market. Digital twins, different scales of instruments and components, or whole plants or whole processes. It's also going to lead to exploring remote presence and sensing. So we're not necessarily in a point in time. We can infer what isn't happening at that point in time and what will happen in the future. So it's important to have this trust and this in measurements and this comparability. And these are things that we're going to be discussing today and tomorrow. Digital units and measurements, quantity types, and we're also working on the types, the measurements and quantity types, a digital version and a standard version. And so we need to have information, the data about the structures that will lead to ontologies for metrology. We will also have the opportunity to look at progress here in the quantity types and the mensurans during these talks. And this leads us to the future, the possibility of standardizing or digitally automating the standard statements, normativity. And once we have this and we tie it in with the digital part of measurements, this will lead us and I'm sure this is going to happen, but I'm not sure when, this is going to lead to virtual auditing agents. Instead of a human agent, there will be software that can carry out that type of process, whether we are complying or not. Also, digital certifications of calibration, and also digital certificates of services, which is what we're interested in my center. Also calibrations, reference materials, certificates, and certificates of accreditation for our accreditation bodies so that they can have a digital version and a computer can evaluate or seek, carry out a search, a specific search, and also CMC digital capacities. This is the progress with the BIPM worldwide, the new system for comparisons of data, key data, and calibration in the BIPM. But it also leads to the human part of it, proficiency testing, and a description of digital certification that includes this knowledge, and also the proficiency testing for demonstrating training competence. So this is what we see for the future from a metrological standpoint. So at the level of concepts, and maybe not looking at the impact, but we will be seeing this in one of the following presentations. As you can imagine then, and as Antonio said, and Pauline too, this is a global effort. It's not just something that's going on in a few countries. And as I was saying, the BIPM and the CIPM and the digital unit system and the FAIR principles. We have the effort in the Americas with the SIM, and there's another group in Europe called Euromet, and at the level of associations, accreditation bodies, the IAC and the NCSLI, and at the level of Eastern Europe, IMECO, and Asia with the APMP. All of us, well, this is just the metrological side. There's also the industrial side and the side of production. They are also working on this and have advanced. In general terms, I'm not going to delve into the details, but you can see the background since the initial publications of the 4.0 industrial transformation, and specific publications from 2017 of the DCC, and some exercise in Mexico, Peru, Colombia, Bolivia, and in 2020, during the pandemic, we had our first virtual workshop. It had been planned for in Argentina originally. In 2021, we were able to execute the second, and today, the third conference on digital transformation. What happened is that 2020 we started and we were very enthusiastic, and I really would like to thank the work of Working Group 14, all of the members who've been participating very enthusiastically, pushing this process forward with good ideas and good work. And this working group that originally in 2020, well, we held the virtual workshop, and this was formalized through the SIM, and there were 22 economies involved. Now we're 23, and the result of this workshop in 2020 was the establishment of 5 task forces. In 2021, we're working in an Inter-American Development Bank to fund these developments, and I'm going to speak a bit about this. There have also been strategic planning workshops for taking action as a group and as nations and individually. At the level of the Inter-American Development Bank project, this is a project which is actually running right now and ends next year. And we have 3 different blocks here, and we'll be able to speak about these during some of the talks that will follow. We have here the automation and remote calibration laboratory under the capacity building and sharing of experiences. And also in the research and development, we've got different projects, and we have the optical 3D measuring systems with dimensional traceability, the metrological evaluation of lung ultrasound, and also using virtual VSM machinery for diagnosis. So we will be speaking about these. And the 3rd block as well, which is the development of a regional public good. And there's a proposal for proficiency testing management based on a blockchain technology. The roadmap that we have imagined from now to 2030, we've got these boxes here in the form of a ladder. These are some of the technologies. We've got the international digital unit system. We've got digital quantities. Here we have the digital certification for calibration, reference materials, the internet part of these things, artificial intelligence and machine learning, digital twins, and everything related to 4.0. And here we're not speaking just about the industry, but we're speaking about smart vehicles, smart homes, and smart cities. Obviously, for this, there's a lot that we need to do, and something that I think is very important and that we will be doing very soon is this aspect of universal digital identifications for individuals and for equipment and for many other things. And we face many, many challenges. As Pauline mentioned, there is a gap there in skills, advanced skills, and the only way that we can develop this is to start as soon as possible, because it is a world of information and knowledge. So that was everything. Thank you. How are we doing with time? I think we're okay. Thank you. Thank you very much, Dr. Hugo Gasco, for this outlook showing us the scope of digital transformation in the region, and we are sure that this will be very important for all of our participants to see. And as we said at the beginning of these talks, we will start with the block of questions and answers. And remember that the questions can be sent through the chat. And I wanted to mention again who they are for, who they're directed to. So Hugo, Gabriel, thank you for your participation. Thank you very much. Can you hear me? We are already a bit short of time, so I'm going to read the questions. So thank you, Paulina, Antonio, and Hugo. The first question is for Paulina and refers to the software. I understand that this the boot camps are a good experience for promoting digitalization. Could you give us an example of this type of event and how the IDB can support them? Thank you very much for the question. It's a very good one. I wanted to start by defining the boot camps a bit, because if you look at the webpage, you'll see lots of things, but in the bank, the format that we are supporting are short-term but intensive programs. It's not part-time or a couple of hours or a couple of weeks, because in that way it's difficult to acquire technology and knowledge. I wanted to clarify that. And also the programs that we've supported, what we do first is we approach the private sector to understand exactly where the gaps exist and what type of digital skills are necessary. And once that diagnosis has been made, we launch a process for boot camps with good background, boot camps that have operated in other countries successfully, and then we invite them to be implemented in another country through a financial mechanism to make sure of a minimum number of students, and we co-finance these boot camps. So if you look at the statistics, for example, in the US, they cost between $12,000 and $15,000, these programs. And we've done this in Costa Rica already, in Uruguay. We're also working with other countries. And really, it's been a very positive experience, both based on the testimonies of those who have graduated, as well as the institutions, the public and private institutions too. Thank you. Thank you, Paulina. I have a question for Hugo and for Antonio. If a calibration certificate is a photograph at a certain time of the metrological reliability of an instrument based on the digitalization concepts, would it be beneficial for the industry and viable for service suppliers of calibration to have a film of this reliability? So, Antonio, Sierra. Thank you. I lost my microphone for a moment. Thank you, Gabriel, for the question. Yes, definitely for us, particularly based on the fact that this is the beginning of this type of exchange of information. For us, it would be very important to have the whole film, because what we will demonstrate to the EMA or to the auditing entity, it's not just the EMA, but it's also ULSC, etc. And we also receive audits from them. So finally, what we would like to demonstrate is the reliability of the equipment, and therefore not just the technical skills of the individuals, but also the competences of the equipment. So definitely the answer is yes. Thank you. Thank you, engineer. Hugo, would you like to comment on this too? Yes, thank you, Ruben, and thank you, Gabriel. Yes, just to complement this, these enabling technologies, well, it's an initial step, and this will allow us, once we're there, well, to think about trends, also mass simulation, multiple different scenarios for testing and for predictions. And if we detect with this film when we need to recalibrate. So there are different examples. The most complicated things will not just be calibration certification, but to have measurements in real time supported by a digital twin, and to be able to simulate and learn and improve through this numerical simulation of these scenarios. So definitely, yes. And not just in production, but also in the sale and distribution and consumption, reparations. So the scope is huge, not just the digital certification. Thank you. So we need to start to work on this, on producing the film as soon as possible. I think, well, time is over. I apologize if there are a couple of questions left, but we need to continue. So thank you. Thank you, Gabriel. Thank you, Héctor, Antonio, and Hugo, and Pauline also for your excellent presentations, and Gabriel for having supported us with the questions and answers from this first block. As Gabriel said, there are some questions that weren't answered because of time, but we will send them to the panelists so that the panelists can answer them. So before taking a break, we're going to take a very short break. I'd like to ask all of you to turn on your cameras for taking a photograph of the participants in the event. Thank you. Thank you. Please turn on your cameras. We are over 150 people present, so I'm going to take several photographs. So, in order to take a photograph of as many people as we can. So leave your camera on, please.
Les agradezco. Un poco más, por favor.
Wait a bit more, please.
Necesito dos tomas más. Un momento, por favor.
Just 2 more photographs that I'm going to take.
Y si me hacen favor, hay varias cámaras apagadas.
There are several of your cameras that are off. Let's see if there's anybody else there who can turn theirs on so that we can include them in the photograph.
Okay, les agradezco mucho.
Thank you very much. Thank you, Francisco. And thank you, everyone, for having turned your cameras on. You can turn them off now. Now we are going to take a break, and we will be back at 1640 UTC. And we will continue with the digital calibration certification and applications with several presentations focusing on the metrology institutes and secondary laboratories. So we'll expect you back after 10 minutes. Thank you.
Bienvenidos nuevamente a todos.
Welcome back, everyone. So I am now going to introduce the new last block of the day, which is on digital calibration certificates and their implementation. So we have Mr. Galvan, who is going to support us with managing the Q&A section. He is a systems engineer with a master's degree in science with a specialty in computers and mathematics. Since 2002, he has been a scientific coordinator of the Dimensional Metrology Department of the National Metrology Center, SIM. He is responsible for the Graduated Rules Center, where he applies methods on algorithms for digital processing of images for longitudinal measurements. He's developed various IT programs for various methodologies, and he is currently coordinating the Digital Metrology Certificates Group, the Certificates Group, MGW14, as he's a technician for the M4DT group under the CAPREC methodology. Thank you, Carlos, for being here with us today and for supporting us with the Q&A section. Now, before we begin with our next guest, I would like to remind you that you can send in your questions through the chat box. And before we end today's meeting, our panelists will be answering your questions. We would like to inform you that due to time constraints, we have reduced our panelists' CV sheet, but you can always access our webpage in order to obtain more information.
Of measured quantities. Unfortunately, due to the time difference between our event and New Zealand, Dr. Blair will not be able to join us, but he has sent us a video of his presentation. We would like to thank Dr. Ryan White and RC Canada, who will be assisting us with questions. Blair Hall leads a project in data metrology at the Measurement Standards Laboratory of New Zealand. He also chairs the APMP focus group on digitalization in metrology and is member of the CIPM expert group supporting the task group of the Digital SI. Blair holds a doctorate in physics from the École Polytechnique Fédérale de Lausanne, Switzerland, and has worked at the Swiss National Metrology Institute, METAS, and at Massey University, New Zealand, where he lectured in physics and electronics. Please, Carlos, if you can support us by showing us the video of Dr. Blair Hall.
Hello, my name is Blair Hall. I'm with the Measurement Standards Laboratory in New Zealand. I'd like to thank the organisers of the conference for inviting me. I'm sorry I can't be with you in person. I'm going to talk about a problem we face in the digitalization of metrology, which is the digital representation of measured quantities. I'm going to talk about traditional ideas for units and quantities and how these limit us because they require an expert user before I try and explain our proposed solution to this in digital form. So the first part of this talk will cover topics which seem familiar to you, but please be aware that I'm trying to draw your attention to details that may need to be reconsidered. Our solution is simple, but it's not necessarily easy to grasp because of notions that we already hold. Well, the idea of units is very old. Essentially, a unit and paired with a reference to the measure can be used to express quantities, but we must keep account of the purpose of the measurement. For example, 10 acres. In the Middle Ages, 10 acres, well, acre was a measure of how much pasture could be worked in a day by a peasant. And so that was a measure used to levy tax, and it would correspond to different surface areas according to the conditions. So we may think of this expression as, in fact, or the acre in this expression as a numeric variable, because if we substitute the tax rate in this for acres, then we can evaluate how much tax would be paid on the particular farm. Our concept of quantities was influenced by Fourier in the 19th century. We're now familiar with the concept of unit-independent quantities, quantity equations like F equals ma for Newton's law. And these relations are assumed to hold independent of the units. And that was, Fourier recognized that there were classes of units that were related to each other through multiplicative conversions. And he attributed the name dimension to each class of such units. He based this in a rather enigmatic way on primary notions of quantities. And he said that they are equivalent to the fundamental lemmas in geometry and mechanics left to us without proof by the Greeks. Well, in practical terms, I think what he was referring to is that there are classes of units in which the zero of the measurement scale is the same irrespective of the unit being used. And when that's true, then ratios of quantities on those scales are meaningful and can be related to each other. So really this concept of dimension is as a class of similar units for the same kind of quantity. So for example, a meter and a foot belong to the same dimension. Along came Maxwell later in that century and gave us the idea of a system of quantities. So Maxwell chose three quantities, mass, length, and time. And taking units for those quantities, he founded a base for a unit system where other derived units could be related to base units through dimensional expressions. He did this for reasons of interoperability, for reasons of communication between people who were working in different unit systems. He wrote that we may be able at once to transform our results from one system to another. And in fact, the practice of capturing the dimensional expressions in the names of our derived units helps this. So in order to evaluate a conversion factor for any of the units, we need only substitute the conversion for the base units into the expression and evaluate it. Well, in Maxwell's day, a skilled scientist would interpret the data, but today we expect computers to do this. And you will see that there are nuances that computers will find very difficult to handle. Let me give you an example. The Eiffel Tower. The architect of the Eiffel Tower, Gustave Eiffel, living in France, might have been expressed as 330 meters. But to Maxwell, living in the United Kingdom, a more useful expression would be 1,083 feet. And in order to convert between these two expressions, we could do as we did for the earlier example of the acre and simply substitute the numeric value of the number of feet in 1 meter for the name meter and then evaluate the product. That seems very straightforward and familiar. But another expression of the height of the Eiffel Tower could be 1.1 microseconds, the time a pulse of light would take to travel from the base to the tip of the top. Again, we could convert between meters and microseconds by knowing how many seconds there are in 1 meter for light traveling at the speed of light. But this is dimensionally inhomogeneous. And so we see from this example that you can express quantities in different units without making it clear what kind of quantity you're dealing with. Here's another example. 0.555 hertz is strictly equivalent to 0.55 per SI second. The hertz is a special name for per second. But another special name for per second is becquerel. So these two are equivalent expressions. But hertz is a special name for the kind of quantity frequency, and becquerel is a special name for activity. And so these are not equivalent. But if the data were expressed in this form, we would not know which was which. Another problem can be illustrated with temperature. If we're given an expression of 12 degrees Celsius, is that equivalent to 12 degrees Kelvin or 285.13 degrees Kelvin? Well, it depends whether we're talking about absolute temperature or temperature difference. So kind of quantity is really needed to understand what is being expressed and to guide us in legitimate conversion. For example, we should say a frequency of 10 per second to avoid ambiguity. And here's another example. If we have 1 kilogram meter squared per second squared, there is absolutely no doubt that these other forms are equivalent, 1,000 grams meter squared per second squared, and so on. But we cannot know whether it's legitimate to transform that into Newton meters or joules without knowing what the kind of quantity is. Now, the problem that arises with temperature is that the SI has allowed different types of scales to be incorporated. Now, a classification of scales was given by Stevens in the mid-20th century, and it's only so-called ratio scales that really work in a system of units. These are scales that can be transformed for the same kind of quantity from one to another by a simple multiplicative factor. But Fahrenheit and Celsius temperature are in fact instances of interval scales where the zero is offset and is different according to the scale. Another kind of scale is the one for angle, where we have bounded cyclical limits, for example, 0 to 360 degrees. And we also have ordinal scales like hardness, where you can rank things in order, or nominal scales, where you classify things like spin up or spin down. So measured quantities are really much more varied than Fourier had envisaged. And to express a measured quantities, we really need to be able to specify 4 components: the magnitude, the unit, the structure of the data, that is the type of scale, which is sometimes called the level of measurement, and the kind of quantity. So, for example, an absolute temperature of 10 degrees Celsius measured on an interval scale. And currently, scientific unit systems don't support this range of components. So a digital format is needed, and one that is needed to support the current legitimate practice, but to prevent accidents from happening. We need to extend current practice to enable digital interoperability, and we should try to support more forms of measured quantity expression because science is using them. Late last year, Mark Custer and I, Mark is chair of the NCSLI Measurement Information Infrastructure Committee. Mark and I published a proposed solution to this problem, which we call the M layer. The M layer will express measured quantities using 3 components instead of the usual 2. We introduce a kind of quantity component, which we call aspect, because we generalize the notion of kind of quantity somewhat. And so we have a 3-component expression. We also generalize the idea of a unit and provide what we call a scale, which combines the type of numerical structure and a reference to an existing scale. Oh dear. These 2 components, aspect and scale, can be considered independent, and we will pair them and to provide full expressions of measured quantities. And in order to allow backward compatibility, there are circumstances when the kind of quantity does not need to be specified, although some facilities of the M layer won't be available when you do that. So here, just let me try and show you a few examples of how this is intended to work. The double square bracket notation is intended to indicate a scale, and the angle bracket a kind of quantity or aspect. So here we see that 1 SI meter measured on a ratio scale is equivalent to 100 centimeters on a ratio scale, or 3.28 feet on a ratio scale. You'll note that there is no aspect specified here because these conversions, these equivalences are considered legitimate. It's feet and centimeters and meters are all in the same dimension. We can express 1 SI hertz on a ratio scale and understand that that is equivalent to 1 per SI second on a ratio scale, but it's not, the converse is not true. In order to recognize that 1 per SI second ratio is equivalent to 1 SI hertz ratio, we need to specify the aspect frequency as well. And in terms of temperature, we can see that 15 SI Celsius degrees on a ratio scale is equivalent to 15 SI Kelvin on a ratio scale, and that's a temperature difference, or that 15 SI Celsius on an interval scale is equivalent to 288.15 Kelvin. So you can see that we're able to give much more nuanced equivalences between measured quantities. And here's an interesting example, which is offered to us by spectroscopy. This was a use case that was presented following the digital SI workshop at the beginning of last year. So these 4 expressions are all equivalent expressions for photon energy that spectroscopists might use. And the M-layer can recognize these equivalences if we identify the aspect photon energy and if we provide the relationships through those equations of physics that relate to that aspect. So the M-layer, we intend this to work in digital systems, and so it's going to be implemented by identifiable digital objects, which will refer to scales and kinds of quantities. And these will be used to index an authoritative register with information, more detailed information about the units and the all sorts of things related to those quantities. To the user, they will see some form of unique identifier without the detailed information. These will be, this is just a glimpse of a prototype. So the final form may look completely different, but the user will essentially have access to the unique identifiers. And interoperability, or the conversion between units, will use those identifiers to access the central register. So for example, if we wish to convert between Fahrenheit and Kelvin, and we're measuring temperature, then we interrogate the register with these identifiers, and if the conversion is legitimate, it will provide a formula to carry out that conversion. So to the user, data would be paired, numeric data would be paired with an identifier for a scale and perhaps an aspect. So here, for example, 10 degrees Celsius on a ratio scale is an expression of data, and this can be converted using the M-layer to Kelvin without difficulty. Similarly, 72 degrees Fahrenheit can be converted to Celsius without difficulty. And note that in neither case did I need to specify the aspect. 10 degrees Celsius on an interval scale cannot be converted to 10 degrees to Kelvin because the type of scale is different. We need to also specify the aspect in order to carry out that conversion. So the M-layer can handle equivalent forms of expression like the meter and foot without requiring the aspect to be included. So this grandfather's current practice, and it we're providing an extension of the notion of dimension. It can also recognize equivalent representations given particular aspects. So here, the case of per second to hertz or becquerel, as long as the kind of quantity is identified. So this addresses the problem posed in the SI by special unit names. The M layer can handle legitimate changes of scale for special representations, such as the spectroscopist's desire to convert between units that would normally not be recognized as related to energy. The use of aspect will disambiguate dimensionless quantities, for example. So things like scale factor, aspect ratio, angle, all of which are ratios of length, can be handled independently. And this is an extension of the notion of kind of quantity. And aspect can also be used to distinguish between different forms of expression, such as rock wool hardness or method-defined measurements. Now, introduction of aspect or generalization of kind of quantity is, the aspect is needed to disambiguate unit references. So it is a very general concept. It is not at all the same thing as a measured quantity. The measurand is very specific, the aspect is very general. So, for example, an aspect would not be a diameter or a circumference or something like that. It would simply be length, the most general description of the kind of quantity that is being expressed. And as I've said before, aspect is very useful for disambiguating various forms of expression. Now, the M layer is not for quantity computations. It's often thought that support for digital units provides this, and that's a misconception. The M layer will support multiplication and division of scales of units, but the objective to infer the kind of quantity from a mathematical expression is much more difficult, and the M layer does not intend to address that question. It's the sort of thing of saying, given that M times A, what is the kind of quantity that F represents? Quantity calculus doesn't really solve this problem, although it's often claimed to. It doesn't distinguish between extensive and intensive quantities. It doesn't handle dimensionless quantities, which are definitely not the same as plain numbers. So there are problems there that remain unresolved, and the M layer can certainly support future efforts to support computations of this sort. It certainly can ensure that type declarations match the data that's supplied. It can check dimensional homogeneity if the system is declared, like the SI, and it will be able to provide kind of quantity expressions, which might be used as inputs to inference engines. So just finally, the M layer encapsulates important metrological notions. It overcomes representational difficulties with the SI, and it extends traditional expressions for measured quantities. It doesn't impose change, but what does enable correct digitalization of metrological concepts. So the M layer is a formalism that handles the greater variety of measured quantity data that science produces, not just the idealized quantities. So thank you very much, and I'm sorry I can't be with you to take your questions.
Thank you very much to Dr. Hall for that excellent presentation. I'm sure you will be able to watch the replay of the event on social media. Ahora, luego de la presentación del Dr. Hall, me permito presentar...
After the Dr. Hall's presentation, I'm going to introduce Alfonso Cotera, who will speak about the certifications of digital calibrations in secondary laboratories. Alfonso Cotera Flores is an engineer, an industrial engineer from the Technological Institute of Orizaba, and he has a master's degree in quality engineering from the American University in Puebla. Mr. Cortera is currently the manager of industrial services for Volkswagen Group Service Mexico, and he is the manager of the Calibration Center for Volkswagen Mexico. Related to accreditation activities for the Mexican Accreditation Agency, Mr. Cortera is an authorized representative of the electrical calibration and acoustic and temperature, humidity, dimensional pressure, force, mass, and torque for the Volkswagen laboratories for the Volkswagen in Mexico. He has 22 years of experience in the automotive field and experience as a university professor. So let's welcome Mr. Alfonso Cortera with his presentation. Thank you very much for this introduction. Please let me know when you can see my screen. I am sharing. We can see your screen now, but we just need it to have it in presentation mode.
Perfecto. Ya se ve claramente la presentación.
See it now, quite clearly. Good afternoon, everyone. It's the afternoon in Mexico. Thank you for being here to listen to some of my experiences. In this part, I don't want to be very technical because behind these data that I'm going to share with you, there is an excellent working group, excellent groups of engineers who will make this Volkswagen project possible. I am just a speaker who will transmit this information. The title is the DCC in Volkswagen Mexico. This part of the DCC, and particularly the changes that we're going to see in Volkswagen Mexico, are accompanied by a broad project which is called Oversight. This isn't just something that's happening because it's fashionable. This is a requirement, a demand. It's absolutely necessary. And there are, well, we can talk about globalized company, digitalized companies. The reality is that for a company to be 100% digitalized, this depends a great deal on its intellectual capital. In other words, the people who are working in the company. And also it depends a great deal on the skills and the leadership of the senior management to align this digitalization strategy in all areas. I'm convinced that digitalization will go step by step. It's not like eating a whole cake all at once, but really the path is everything for everything. So in digitalization, it cannot be partial, and you cannot think about completing it in the future. It won't work. This is why I've always been working together with the CENAM researchers. And on some occasions, well, I've invited them to give a talk, and I remember that when we became aware of the needs for digitalization, and we developed a match with CENAM, and CENAM with the BTB, and I said, well, I'm your client, CENAM, and I have these needs, they're significant ones, and I need digitalized information. My clients, the ones I provide calibration for, also have the need to have digitalization. But what follows on? So in this slide, what we can see is how Volkswagen is deciding, and myself as the calibration services of Volkswagen, accredited and non-accredited, are looking at certain levels that we need to go through. I'm not saying that all manufacturing companies should go through these levels, but these are the ones that we already have aligned. We've worked on these, and this is a level of a value chain, the famous value chain, where the primary laboratory first of all wants to understand the impact of this And a long time ago, my son told me, he said, "Dad, you work in Volkswagen?" Right. And I said, "Yes, I work in calibrations and metrology." And he was, didn't really know what I was talking about with this science. But then I realized something very important there. I didn't manage to explain things all the way through. And I place this before you for your consideration and for all suppliers who are carrying out calibrations and all of the excellent suppliers that we have in the Republic and in other countries too that provide services for calibrations. This is worth reflecting on. And it's very closely related to DCC. This reflection leads us to ask, well, the calibrations that I'm selling, the calibrations that I am offering the industry, whether it's the automotive industry or the manufacturing industry or whatever, have we actually visualized what the impact of it is on our services? It's complex because, well, sometimes as clients, we don't even have any idea of the impact of calibrations. And I would dare to say that I have lived through this culture, a very deeply rooted one, working for the auditors. And I respect the auditors. And it's because of them that we can make improvements. But I have a problem with the quality culture. I work for the auditors. Well, I don't really do that. I'm just, I contract the calibrations. I contract my suppliers for them to calibrate and give me a calibration label. And I'm thinking, well, I've already complied because when my quality audit is done, the first, second, and third part, whatever we want to call it, I've already complied because I'll be able to demonstrate to the auditor or to the evaluator, the assessor, that I've already calibrated because I have the label. We're not having an impact, really. And I put myself in the shoes of CENAM to wonder about, well, the whole science and all of the conferences. All of these presentations have been excellent. The previous one, just before me, had an excellent proposal of uncertainty. All of this, well, have we really managed to capitalize this for our benefit? This comment that I'm making, I'm trying to capitalize, take advantage of this, and I'm trying to share this, share what my levels are, level 1, 2, 3, 4, and 5. From the time when CENAM will send me a report with a calibration certificate up to the value. So this slide tells me on the left, I apologize, CENAM, but this is what before this was what was necessary, and it was very complex. So look, what for me was really complex to disseminate this measure and to capture these values. In fact, what we hope to achieve with the DCC is this, to make it much leaner. And there, well, we've considered many, many important things in Volkswagen, and we've managed to reduce many, many things, resources, etc., because we started to work with DCC, the levels basically, and I'm going to comment on this very rapidly, how we've worked on them. And CENAM issued the calibration certificate through DCC, and of course with this DCC, I will read it, of course, and also with the assistance from CENAM, we will be able to read it together with the coders so that I can carry out a self-calibration. With this self-calibration that I have, I will issue a calibration report based on the DCC for my client, my direct client. They're the laboratories, technical development centers, research centers. I'm going to support these laboratories and these centers that I have in the company so that they can also report this. They're not going to produce a calibration report. Basically, it's testing, but testing is part of a DCC, and with the DCC, we will have an impact on the product. And I say that finally, thank goodness, for the DCC, because the DCC opened the doors in order to have an impact on the value chain. I don't want to say that we didn't do this before. We did, but it was an extremely complex process. The audits, well, the auditor would ask for things that for us wasn't viable. And so we started to discuss this because we never managed to convince the auditor how we could have an impact with that part. And it's not a question of convincing the auditor, it's a question of convincing ourselves that the calibrations are an investment, not an expense. For me, it would be an expense if I have to take money out of my pocket, pay for a calibration, and I don't see any benefit for it. Well, the benefit is that I have a label, and so I've passed the audit, but it's basically an expense. But the calibrations will be an investment for the company when we're really aware that the data will have an impact on the product. And these are the levels that we're sure of in Volkswagen. Also, Senam has been supporting us a great deal in Volkswagen, but we're very sure, both parties, 100% sure that now, yes, we will be able to visualize. And I'm not saying that before we never had an impact, but we will have better control. We'll be able to visualize the dissemination of the measure. And as a company, I call that the value chain. My most important challenges that some other companies as well that are already implementing the DCC are going through this as well. How can I capitalize an investment area in a company by saying so, and that this is what we have to do, and it's not just because it's fashionable. We need to capitalize it. We need to convert the benefit into money. We need to convert this part, including the person who will start capturing the data, because we won't have people that we need to capture data. We need systems engineers, specialists in digitalization. So you mean to say that you're going to reduce personnel? No, we need more people, but with more specializations. Another important challenge for the company, and my systems supplier has always told me, Alfonso, be very careful with the DCC. I'm not going to authorize anything until you don't guarantee that you're going to safeguard the company's information. So this is a challenge that we need to understand. We cannot take another step until we safeguard the data. And also, as a German company, everything's based on standards, and I have to demonstrate how I'll have an impact. In this case, Volkswagen Mexico, we're going through processes in Area 5, and this is pure statistics. We have to demonstrate statistically that the processes are efficient, and to demonstrate this, there's a very important part to this, which is called uncertainty. One of the variables that's important for liberating a product or a process is a calibration uncertainty, the equipment that control the processes. That part is the challenge. How can we make this DCC from Senam and until we can achieve an automated platform as a contribution? So we need to progress with this, and I've carried out tests, mainly temperature, and we have advanced here. So how it will have how will this have an impact on a metrological system? And as an engineer, well, we know design, development, implementation, improvement, systems optimization. That's my job, but based on the metrological system. So how can I have an impact on the system as a whole through the DCC? And also, we've seen good results. We've reduced considerably this complexity of the quality system with so many documents and control letters that have been required. We've managed to reduce this considerably. And finally, to make it into a system, we cannot have a DCC as just one more activity in the company. It needs to be systematized. So at the end of this film, I would have to demonstrate when we finish this I'd like Sinam to invite me to give a talk about how this film concluded, because everything, all of the values that uncertainty values that we've achieved. When I buy a calibration service, I buy the service, but mainly I'm buying this uncertainty level. And this uncertainty, I'm going to translate it into the capacity and skill of my processes for robust products that comply and that even overcome the client's expectations. This is a huge challenge, but in the end, in the European industry, I need to demonstrate level 5. And if I can't demonstrate the DCC at this level, there are going to be problems with my directors because of that situation. So just something that's just become fashionable, but nothing more. So the DCC is here to stay. It's here today and it's here to stay. And it's been giving us very good results. This is a timeline for the project. I didn't want to include the date because we depend a great deal on how we work with Sinam and Sinam with the PTB. But this project shouldn't go beyond 2023. Ideally, we've already implemented a considerable percentage, and we're going to have by December certain benefits available, and by February we'll have at least one magnitude of a value chain. It'll be temperature. And this is why digitalization needs to take small steps, but strong and safe steps. So rapid benefits, so that I don't really make this presentation too long, the main benefits that we should keep in mind in a DCC are, or in a manufacturing company, and I need tangible benefits because this results in yield. So I should have an impact on quality, obviously. I mentioned BDA 5. I need to make sure that all of the mistakes, because of this part of the difference in systems in a company, that we need to eliminate these errors by automating the value chain. Mainly also, we need to automate the whole system. We do it through software called LabVIEW. So we need to automate this. But there are certain parameters. The DCC is ideal for this. In human resources, we're going to reduce operations. We're going to have a leaner administration, and we need to focus on efficiency. We're going to also have a specialization services instead of a data capturer, and we're going to have to think about new job positions as well with these specializations, and also eliminate human error. I would say completely. The financial side, well, we need to automated purchase orders, and we need to transmit this message that this really will have an impact, a significant one, on the company's finances by optimizing resources. And optimizing resources doesn't necessarily mean reducing. It means doing more with less. And well, we're speaking about productivity here. And if the DCC doesn't provide productivity for me, which is another way of making more products with better quality between the resources utilized, well, there's no way, no objective way to justify a DCC. But so far, the truth of the matter is that DCC is here to stay. The digitalizing certificates will help us a great deal to change our culture and to stop thinking that calibrations are just for complying with the auditors. We will be able to have a better control and thus have an impact on the value chain. Thank you. Thank you very much, Engineer Cotera, for this excellent presentation. regarding your industry, and it's related to all of the topics that we've been discussing and the importance of metrology, as you mentioned during your presentation. I'd like to remind you that your questions, you can enter them in the chat, and don't forget to say who your question is for. So let's go on with the last presentation of the day, experiences in the DCC Summer School, which will be presented by Mr. Ruben Gil and Edwin Kuhlman. Ruben is an engineer in telecommunications with a master's degree in electronic sciences with a specialization in automation and control. He has experience in project development and services in the area of gas flow, including calibrations and verifications, technical expert of metrological verification. He has experience in developing hardware and software after the digitalization and automation of measurement processes. He participates actively in digital transformation for 4.0 and for digital calibration certificates. He's a member and representative of Peru, the Working Group 14, called Metrology for digital transformation of the SIM, and he is the current coordinator of his working group automation of laboratory processes of the Working Group 14 of SIM. Edwin Kuhlman is an electronic engineer with a master's degree in industrial automation with over 10 years of experience in metrology. In the last 5 years, he has led the automation process for measurements in the National Metrology Institute of Colombia, INM, creating innovative solutions for laboratories in other areas of the Institute. So let's give them a warm welcome, and we thank you for your participation in this conference. So go ahead, Ruben and Edwin. Thank you very much for this introduction. Can you hear me? Yes, we can hear you. My colleague, Ruben, can you hear me? Well, let's try your sound. Yes. Thank you for this introduction. Welcome, everyone. Thank you for being here in this third annual conference. So go ahead, Edwin. Thank you, everyone, for being here today and on this occasion. My colleague from the National Institute of Metrology of Peru and myself, we are going to share our experiences in the summer school of the digital calibration certification that was this year. We would like to start by talking about this concept, which is the international unit system in the digital framework. This concept is one that covers most of what we've been discussing today. So from the metrological world, there's an awareness that the international unitary system is in the digital era, and for this, this system has been established in this digital framework. So much so that the large institutions such as BIPM, for example, have defined a vision for this digital framework in the international unit system with these concepts, IT concepts that are in layers. So this vision was defined. And as part of this process, we also have the FAIR principles. The FAIR principles with a digital information that needs to be accessible, easy to find, interoperable, and reusable. So regarding this framework, this concept, different efforts have been made so that the metrological world can progress in this sense. And we have the enabling technologies such as lab automation, artificial intelligence, machine learning, the metrological cloud, and what we're speaking about here, digital calibration certificates and other technologies, enabling technologies within this framework or the international unit system in the digital framework.
Okay, adelante.
Yes. For many of the countries in the region, the digital calibration certificate is completely new. I'm speaking here about, in general terms, this is our perception. And many institutes thought that we had already implemented a digital calibration certificate. And now, after these technical talks, we consider that that isn't the case.
De lo que es un certificado de calibración digital, un DCC.
I don't know if maybe we didn't understand what the concept was, but it might be that the countries are transitioning, and in some cases it might be necessary to strengthen these administrative processes, and some institutes are working on improving their platform for providing customer support. And in other cases, it might be necessary to improve automation and digitalization processes regarding measurement results, because many have processes which they've developed themselves, and they're trying to expand this towards the various laboratories within their institutes. Others are thinking about creating a single platform for entering these measurement results, and in other cases, they are thinking about standardizing the information regarding analog information entering. So, I could go on and on, because there's a broad spectrum regarding levels and progress in terms of digitalization. And I'm focusing on digitalization, as I was saying before, because this is the basis for the DCC. And it's important to mention that there are countries in the region which have an advanced DCC for certain magnitudes, and they are testing in the industry, as Alfonso Cotera from Volkswagen Mexico just mentioned. So go ahead. So now regarding INACAL, in relation to the DCC, I'd like to first mention how it is that we've been working, because we have a 24/7 online platform which allows the users to enter administrative data. So we've actually digitalized this part, and then the data is entered when we deliver the measurement tool through a local system, which is called the Metro system. And we then carry out the calibration process, and this depends on each laboratory. For example, there are certain laboratories which have an advanced automation system, others have a semi-automatic processes, and others have manual processes. It depends on each process, and this process generates a template. Everything is entered into this template in an automated or manual manner. So that is where we digitalize the measurement data. Lastly, the Metro system combines the administrative data with the measurement data, and it is all entered into a PDF document, which is then signed by the head of laboratories and the head of the corresponding area using an electronic signature. So for the DCC, that is the level we're at. So we have digitalized the administrative data, the measurement results, and we need to move on to the next step, which is to migrate to the DCC through the schemes recommended by various institutions, and using platforms and others such as XML. Go ahead, Edwin. So as was said by the Peruvian Metrology Institute in Colombia, we have done this based on the proposal regarding the DCC scheme proposed by PTB Germany. And in order to approach this scheme in our institution and the Colombian Metrology Institute, there have been many questions from the technical perspective, on how to address each of these steps in each of the standards. So there have been many questions which we've had to address from the technical, administrative aspects, from the social point of view, how the DCC impacts our industry. And now thinking about this, thinking about developing ideas and thinking about responding to the DCC within the INM, we've developed these analysis on how the various measurement data behave within these files, the Excel documents and those other files where this information is processed, and how to incorporate this into this proposal, how to incorporate it into an XML document. So we have begun working on this, and that's where we're at the moment. And it's important to consider it because, it's important to guarantee the data are reliable and that we have the adequate information, because we're asking ourselves, how important the digital calibration certificate is and how safe it is, or how secure it is. And that's what we're currently addressing within our institute. So now this leads us to an important question we've asked ourselves within the region and as a working group. Why is it that the calibration certificate is necessary in metrology? So now, at the moment, we are facing complex challenges in society, and we've also been going through critical times. So metrology needs to respond or address these challenges. And a way to do this is through a digital calibration certificate that guarantees traceability, guarantees that information will be maintained in a secure manner. And in addition to that, it's important to think about why the calibration certificate is or why calibration certificates are important. And that's because there are other technological tools being used which are compatible, and there are many pieces of data being generated, and they make calibration certificates necessary in the metrology environment. Additionally, measurement infrastructure is being digitalized, is being constantly updated, and this is also important because the calibration certificate to lead us to becoming more advanced in terms of technology, because the calibration certificate will be able to be read by humans and machines. So, as was mentioned at the beginning, a considerable percentage of institutes in the region didn't know about DCCs, but with various activities and with the support of cooperation projects, this gap has been gradually reduced. And there are many activities in the working groups, for example, Group 14 of the SIM and the Digital Calibration Certificates Group have been supporting us with this. And there's the CABRAC methodology, which has been working on DCC with support by the SIM and PTB have been working on this. We also have the M4DT days and the M4DT conference. We're actually working on the 3rd annual conference. And there are also international discussions organized by the National Metrology Institutes and international discussions or international meetings organized by various international entities, and another meeting organized by the PTB Germany, which have been supporting us with reducing these gaps. So I was just mentioned by my colleague, these projects and activities have been supporting the INM Colombia. So they have been supporting us with addressing these digital challenges, such as developing metrological assurance tools and well, other aspects, for example, including Metrology 4.0, artificial vision, knowledge transfer. And as we develop these tools and we participate in these activities, this also contributes to the development of a hardware for metrology, which is extremely useful, and the validation of software, because software is extremely important in this area. So we've been developing validation processes in order to make the software more reliable. And it's also been supporting with collaborative work in the region, because we have NMIs sharing experience, ideas, and working on the development of processes. And we've also been creating tools for establishing information at the statistical level. We've also been exchanging with other NMIs established within these discussions, and we've been transferring knowledge in terms of technology, because the institutes have been encouraged to develop technology and knowledge to be shared with other entities. Now, the digitalization we've been developing within NCAL has helped us support our clients during the pandemic. And the pandemic has also led to us developing more technological solutions, and participating in these events regarding digital transformation have allowed us to learn about more technology and success cases. And it's helped us with moving forward regarding more projects, which we've thought about working on in the medium or long term. And we've also been sharing what our success cases have been. And in terms of digital calibration certificates, we're developing an internal digitalization proposal so as to migrate in an efficient manner towards the use of these digital calibration certificates.
Okay. Entonces, ¿qué es la escuela de verano?
So what is the summer school regarding the digital calibration certificate in 2020? So this summer school was created in Germany at the PTB headquarters in Brunswick, which is a beautiful city. And
compartieron sus conocimientos y desarrollos de toda esta tendencia, necesidad, desarrollo de este concepto, utilidad.
Metrology Institute concept. They've spoken about the use and the importance of this concept, which we're currently working on as a Metrology Institute. So during the summer school,
Fue por 5 días.
It lasted 5 days. And they addressed various topics, as Ruben was saying. And they also spoke about various tools which were useful in order to work on digital calibration certificates. And they spoke about XML basic aspects. They spoke about good practices. And they spoke about the GMMG tool, the XPath, which is used to manage and introduce XML information. They also spoke about Shematron, and there were various review courses. For example, the DX, there were group exercises, individual exercises. So it was a very complete course. It was a 5-day summer school, as I was saying, on digital calibration. And there was also information on data and software in order to generate a DCC. And we also had the participation of various continents, all continents, basically Africa, Europe. And it wasn't only for Metrology Institute, there were also laboratories, people in the industry. There was also the SIM that participated in the summer school. And this contributes to a collective collaboration, and that's what we have been doing since the summer school course. So in general terms, I think the summer school was a great experience for all participants. First, because the topics covered and the information provided throughout the week was extremely valuable. Many participants allowed or were able to learn about the technical aspects, and there were other people there who had more knowledge about the DCC, but they were able to consolidate this knowledge. And after the course, there was a practical exercise on data acquisition, digitalization, and on, well, generating a DCC. So it helped us learn how to develop it and develop it well. And what was important was that we were able to interact with people from different parts of the world, and we were able to find out how people are thinking about working on the DCC in their own countries. So it was very valuable to learn about what each country's reality is, because in some cases they have an industry that actually needs the DCC. In other countries, they don't have these industries, but they do have secondary laboratories that could benefit from the DCC. And this level of interaction also allowed us to learn about the technological tools with which they're working, and how the personnel involved with the DCC works, what they do. Now, INACAL is currently participating in a regional project. So by 2023, we're thinking of preparing a demo on the digital calibration certificates regarding the weights and balances calibration. So we know that this is something new in our country. Therefore, we believe that awareness raising presentations are very important. So we are thinking of providing these presentations internally within our laboratories first. And we're also thinking about taking advantage of the discussions and seminars on the DCCs, specifically those to commemorate the World Metrology Day. Peru has many secondary laboratories which work with various industries, and these laboratories have various levels in terms of progress made in digitalization and with processes. And that's a reason why we're thinking about developing a workshop to teach them how to develop this DCC. And through the platform, we like to have them be able to generate
a sus procesos. Algo importante es que estos laboratorios secundarios reciben bastantes certificados por parte nuestra, ¿no? Bastante información. ¿Y cómo lo integran a sus sistemas de gestión? Pues de forma manual. Entonces, como se mencionó, como Edwin mencionó, entre los beneficios del DCC, queremos que con nuestro soporte, nuestro acompañamiento, estos laboratorios puedan integrar el DCC a sus procesos y con eso hacer más eficientes los procesos de ajuste de instrumentos, cartas de control, entre. Finalmente, el estar preparados tecnológicamente para afrontar el DCC permitirá atender futuros servicios a la industria 4.0. Adelante, Edwin.
Listo. Para el caso de Colombia, después de esta escuela de verano, y también hemos venido trabajando pues, a partir de esas preguntas que nos hemos hecho y a veces también dándole respuesta. Para Colombia es el...
So for Colombia, it's the DCC or the Time and Frequency Laboratory. So we are proposing that prototype, and this is oriented towards a service in Colombia. So that's where we are making our first efforts for the National Metrology Institute of Colombia. We're also participating in the Cabaret project, and we have an objective for achieving the DCC in the Time and Frequency Laboratory for this service. And one of the specific objectives is to implement it in this laboratory and to take steps, the appropriate steps. And the project has helped us to do that, and the other tools as well that were presented during the summer school. These have also contributed towards achieving the objectives. A second objective is stabilization as well, because this will interact with the different platforms and with different data, and also the user, which is very important both for our internal users in the institution as well as external users. And also there's a third objective, which is this adoption by the clients or by the industry. So we are, as my colleague Ruben says, we are on our way to 2023, and in the next 18 months, we can achieve the first DCC for the INM in Colombia. Yes. So, when we speak of the perception of the impact of the DCC in the region, in the SIM, the development of the DCC helps us to understand and to use this type of technology in the international unit system, or international system of units in the digital context. So this is an initial approach. So one perception, this is an effort with the different INMs in order to approach all of the challenges of metrology for digital transformation. So we are achieving this in the region, and also these certifications need to be machine readable for the industries in our countries. Well, finally, I wanted to indicate some conclusions and comments. The summer school provided an opportunity to learn about DCC technical issues and the perspective of participants, the type of scheme that a digital accreditation scheme should have, and as well as the perspective of participants, which is one of the most valuable things. Also mentioned was that there would be follow-up to the summer school, basically in order to demonstrate progress, how we're doing, what we've been doing, and also a more specific training, more advanced training. And finally, one of the talks and the conversations with colleagues, well, it's recommended that the development of this CDD be a collaborative effort between each institute and the area of metrology. And so it's very important to define this process, this union between the IT area. So that's everything. Thank you for your attention, Edwin. Okay, thank you. And I'd like to thank all of the participants.
Thank you, engineers Ruben Gil and Edwin Culma, for having shared such an interesting experience with the summer school. So let's remember that this event was organized by the PTB in Germany. So let's now begin with the Q&A session. And as we said at the beginning, we have Carlos Galvan. I'd like to welcome you again. Carlos Galvan, you have the floor. Carlos, we can't hear you. Can you hear me now? I was having a problem with my mic. Thank you, Germán. We will now continue with this block. I've seen in the chat that there are several questions, and I'm going to begin with the first question.
And the question is, what kind of computer tools, like languages, data structures, metadata, could help to create the M layer? Is there a prototype that shows how it could work? I guess that Ryan, that is here, also write an answer, but I would like if you can extend this answer, Ryan, please.
Hello, thank you. Yes, there is a prototype available through the APMP Digital Transformation Organization repository on GitHub. It shows some basic concepts that metrologists can learn about, and it also serves as a way to communicate these requirements to, say, technologists, software engineers. Also in progress is a technical specification of the data model itself. With these two, we can certainly be able to engage with software engineers in order to develop solutions as well as the database structure and applications that we put on top. So one thing I like to emphasize is that when we specify these data models, we'll be able to present solutions where we can leverage digital technology and kind of remove challenges of trying to sort these problems out ourselves, right? So that's one thing that we should keep in mind in this effort to transform digitally, is that we simply need to, as metrologists, explain our concepts and then make sure that our technologists can help us realize these solutions. Thanks very much.
Tu micro está apagado.
Your mic is off, Carlos. Thank you for your excellent response, Brian. So we're going to continue with the questions. So the next question is in Spanish. This is for Alfonso Cotera. Fernando is saying, do you think that the advisors and auditors should be trained, those who are going to be evaluating the DCCs? Do you think they should have IT skills? Thank you, Dr. Galvan, for having read that question. So we should all be trained in reality. I mean, it doesn't have to be a detailed training, but I'm sure that in the next few years, we're going to be learning about this. So it doesn't have to be detailed, but I mean, they don't really need it. That's the advisors, because what they're going to ask from you is what the system management establishes. So the companies are going to be showing that they have a calibration report, that they have their label, as I mentioned during my presentation, and that's it. The auditor wouldn't have to really decipher the DCC. So the auditor, obviously, I don't want to go into too many details, but I mean, I don't think you, or I hope you don't have any calibration laboratories of this type, but I'm imagining that a client will come to the auditor and says, okay, can you show me your calibration report? Of course, yeah. So, and that they say that send the DCC to the auditor so that they decode the information. I mean, this wouldn't be correct. So, I mean, that wouldn't be a real case. I mean, this wouldn't happen. So, I mean, the auditors are going to read a PDF report or a printed report, so they don't have to really decipher the DCC. So I don't know if this answers your question. We can't hear you, Mr. Galvan. Thank you for your response. Now that you have the floor, we have another question here. I can barely hear Mr. Galvan, so I'm trying to do my best. Do you think we should work with cybersecurity systems to protect information confidentiality? That was an excellent question. I actually mentioned this during my presentation, and let me give you an example. Volkswagen isn't going to let me enter with a DCC until the systems engineering department ensures or protects the information managed in Volkswagen. So we do have to work with the security team, and we have to be careful with the cybersecurity attacks, but that might not be the response. However, I do want to highlight the fact that we can't stop moving towards the DCC future because we know that there might be a cybersecurity attack, because this is a reality. So this might not be the response you're expecting, but the message here is, yes, we do have to work with the cybersecurity systems. However, let's not stop using a DCC because there might be a cybersecurity attack. Excellent response. I like your point of view. I don't think this should be an obstacle regarding the DCCs. Thank you very much, Alfonso. So let's continue with the next question. We have several questions for Ruben and Edwin. I think that his presentation was very positive, and there are many questions here. So the next question is, how do you carry out your digital signatures, and what platform do you use? Would you like to go first, Ruben?
Just quickly, we started by signing on paper and then scanning it and sending it by email. And well, then we had the PDF, and on that we could scan the signatures of the others as well and transfer the image so that we have an electronic signature, which has been regulated by the National Registration Organization of Peru. And this guarantees the authenticity of the document and its safety. And this we do through our own platform that we've developed here together with this National Identification Authority in Peru. And so this is how we've been working on it. In the case of Colombia, it's very similar. We have the system that prepares the PDF with all of the information and the measurement data as well. And when we want to use the digital signature, we have a service in Colombia. It's called Certicameras. And this service is through a web service, and it places the signature and the time stamp of this PDF. And well, so there are two different stages. First of all, we have the stage when the person who calibrates goes into the platform, enters the information, and records it. And we do it through Certicameras. They place their digital signature, and then it goes to the next body where it needs to be reviewed, and it might be sent back. But anyway, they also sign this document digitally. So when it reaches the user as a PDF file, they can see exactly when the documents was signed and who signed it. Thank you. We're going to conclude with a question, but I think it's an important question, even though time is almost over. Have you made any analysis of secondary laboratories to determine whether they are prepared for providing or for consuming this service? Well, I think, it's a very important question, in fact, and this is a good way to close this morning's talk. So definitely, when we started with this, we said, well, this isn't going to be useful to us. because it represents too much investment in time and resources for our users. With what we already have, everything is working well. So what additional benefits will the DCC provide? The benefits that have been mentioned during today's talks, these are significant benefits for the industry in Mexico, such as Volkswagen, where there's a need to digitalize the information to make the processes more efficient. In our case, it's not exactly the same. So how beneficial would this be for our users and for us as a National Metrology Institute? Maybe not so much. However, if we think about these certificates that we're issuing to these secondary laboratories, we've made an analysis, and there are some laboratories that receive a large number of certificates from us. And so in some cases, these certificates contain quite a lot of information. And they've been filled out manually. And sometimes there are problems when the information is transcribed or entered. So we have seen a direct benefit in that sense of the use of the DCC, so that these secondary laboratories can have a legible certificate, not legible by people, but by the IT systems, and thus make their processes more efficient. So, for example, automatic adjustments, more efficient control letters, and many additional elements based on the digitized information available. So that's the direction we're heading in. And this will make it possible that in the future, once we start to attend the 4.0 industry, which is closer every day, we will already have the technological tools for doing this, and we won't be starting from scratch. So from that point of view, we're working on the DCC. And it's similar in Colombia. The contributor to this has been the Cabaret project, because, in the first step, we have the awareness raising of this technology, the digital calibration certification. And so, we've raised awareness internally so that people from different areas of the Institute know about it. We've also carried out surveys. So this awareness raising has been done well in the industry. And we've given talks to raise awareness there. And we've also prepared a survey to investigate the possible use of digital calibration certificates by our industry. So that's what we have, or what we've achieved rather so far. And we will continue with this because we are committed to providing a service. So the first step was this, and in 2023 we will start to extend this. So that's what we've done so far. Thank you very much, Edwin and Ruben. Thank you, Alfonso, too, for your participation. I think, we've generated a lot of questions, so that means that it is something that people are thinking about. So DCC, as Alfonso says, is here today and here to stay. So thank you, all of you, all participants, and let's close this block on digital certification calibration. Thank you very much. I'd like to thank all of our experts who have been with us today and remind you that tomorrow will be the second day of this Metrology Conference for Digital Transformation at the same time, starting at 1500 hours UTC, and the topics will be automation of artificial intelligence and its applications in metrology. And I'd like to introduce again Dr. Hugo Gasca to close this first day of this conference. Dr. Gasca, welcome again. Thank you, Herman, and I'd like to thank all of the speakers. The talks have been excellent. These technical talks with a certain level of complexity and detail. I'd like to thank all of the participants too, who managed to connect today, and we will hope to see you again tomorrow. Tomorrow's content is also very interesting, automation and artificial intelligence applied to metrology. So, well, it has been a pleasure. I'd like to congratulate you all for the efforts that you are implementing at the regional level. And as Carlos says, and Alfonso, this is what we need to work on. We need to plant the seed and harvest as soon as possible regarding innovation for metrology. So thank you very much. I declare this meeting closed. Thank you and good afternoon.